Okay, so aldehydes and ketones, they have a functional group that we call, or if you're in biology, you're probably going to call a carbonyl group or carbonyl. Um, we're really looking for what is it an aldehyde or is it a ketone? So again, these molecules actually, many of them have common names. Maybe you've heard of formaldehyde. Perhaps you've heard of the keto diet. So these molecules, first of all, we make use of. Also, they have a big impact on in our biochemistry. So again, when you take 12U Bio, you'll talk about these as well. So an aldehyde and a ketone, the only difference is where is the carbonyl group found. So if it's an aldehyde, it's found at the end of the chain. So however long your chain is, versus a ketone where it's found somewhere in the interior. Or not at the end. Sometimes when we have aldehydes especially, it's like the notation sort of messes students up. So really all we want to do is emphasize that it's at the end. So sometimes people will do this, showing that it's a hydrogen at the end, there's no more carbons, which is sort of weird. So if you would rather just do a tick, okay, it's just trying to emphasize it's at the end of the carbon chain, no more carbons, okay? And then a ketone, I've drawn it on the second one here. It could be on the third, anywhere in the interior. So the reason that we sort of classify the molecules as like this, is because some of their properties. So maybe you've heard of acetone, which is it's a common name for 2-propanone. So it is a ketone that will remove nail polish. And the fact that it's removing nail polish, it can tell you how strong of a chemical that is. It is, what's it called? Very smelly, yes. You would know the smell of acetone. Anyone who's ever put nail polish on, have you ever got acetone or nail polish remover on your like coffee table or anything like that, and it takes the paint off because it's a non-polar solvent? It's actually dissolving this varnish on your table and stuff. So it is a very powerful solvent, very flammable, okay? Versus aldehydes, which are often used as preservatives. So we used to use formaldehyde if you dissect things. Sometimes the frogs are dehydrated because it's safer. Formaldehyde can be carcinogenic. And formaldehyde, which is also called methanol, is often used as a preservative, sometimes in wood products like laminate flooring and stuff, and sometimes in makeup. So it's like they're trying to sneak it in. Like instead of calling it formaldehyde, which is the common name, they use methanol. So if you're reading your cosmetic ingredients, make sure you're looking for that. Lots of times when you buy pressed wood products, like something like this desk or like laminate flooring, something that's synthetic, basically, it'll say formaldehyde free. That's good. Or if you've ever bought anything, like I'm thinking of, those pads that you interlock and you put them down so kids can play on them, and you open them up and it's like, whoa, what is that smell? It's usually from the preservatives, the aldehyde preservatives. Okay, so again, and we talked about that in grade 11 with off-gassing, like materials that you should ask yourself, should I be smelling this? Okay, so those kinds of things, be a savvy consumer. So ketones also, so we do produce a little bit of formaldehyde in our bodies. but ketones as well. So ketones, and those of you that are into health and talking about the keto diet and ketosis, so that it's controversial because, for example, I'm a type 1 diabetic. If my body is producing ketones, that means that I do not have enough insulin. I'm not reading my levels correctly. My blood sugar is out of control, and my body is actually turning it into ketones, which is toxic. It can make you vomit. So they talk about ketosis and acidic ketosis, and you're really changing your body chemistry. So will you lose weight because you're eating less like no carbs? Yes. Are you doing it in a sustainable, healthy way? You have to be really careful, okay? So you're producing ketones, which are processed by your body differently. Your body still needs glucose, but then, so instead of ingesting sugar and getting the glucose from that or carbohydrates, your body is processing food differently using ketones instead, which is better in terms of quick weight, or not quick, but dramatic weight loss. But is it good, long-term, sustainable? They're not really sure. Okay, so there is a lot of places that aldehydes and ketones are found, and some of them you should be careful about. But your body makes it too, so it's all about balance. Okay. Should you drink nail polish remover and ingest it in any way? No. Okay, so those kinds of things, those are synthetic chemicals, stuff like that. The good news is they are very straightforward to name. Okay, so aldehydes, because it's always at the end of the chain, all you have to do, let me just pick count the number of carbons and add the ending Al. So just like alcohols, aldehydes, the ending is Al. Ketones, the ending is ONE. You change the ending to ONE. Because ketones have a different place they can be, you do have to include the number, but for aldehydes, it has to be at the end, has to be number 1. So often it's written like this here. Actually, I guess those would be the same. If it was propanol, butanol, if you want to write the 1, that's fine. But again, when you go to do the questions on homework, your textbook probably won't, okay? So methanol, that's it. Ethanol, again, it doesn't matter which side. Let's do hexanol. Decide if you want it to be on the right or the left. You can write it in the top, write it in the bottom. That doesn't matter. It just has to be at the end of the chain. How much room do you guys have here? So for a ketone, you have to say the lowest number where the C double bond O is. The double bond O now counts for 2 of carbon's bonds, so that takes up 2 spots. That's important as well. So now this one, it's in the interior. 1, 2, 3, 4, 5, that's pent. And similar with alcohols, we don't say pentol, we don't say pentol, we say pentanol. So same thing here, we don't say pentone, we say pentanone. If you just wrote pentone, I wouldn't take marks off. And then you need to say where it is. So it's on number 3, no matter which way you count, okay? Your textbook loves to ask sneaky questions like, can you have methanone? No, because it would be at the end. That's an aldehyde. They love to do things like this. Okay, this can't be cyclohexanal because there's no end, right? So it has to be a ketone, which is really sort of sneaky. If you wanna try to sneak that in there, so because your textbook, I don't know, they love that. Okay, so aldehydes and ketones, again, no OH, just like ethers. So if you want to jot that down, so if they are small, they can dissolve in water. So if you want to sketch this little picture, like we've been drawing, okay, where it can accept hydrogen bonds from water, but there's no H. There's O, no H. That's very important for hydrogen bonding. I was just talking with Johan, so one of the questions asks you to compare, I think it's an alcohol and an alkane, which is nonpolar. Even if you forget that the alkane only is nonpolar, which is London dispersion, then you can reverse. You can talk about the alcohol, that it's got OH. It can make hydrogen bonds. So hopefully that's been one of our focuses as we do this, okay? Again, it says when small, so like less than or equal to 4 carbons. But again, solubility and polarity, that's sort of iffy, okay? That's tough for you to rank. Usually I try not to pick that, unless it's like polar versus nonpolar, like super obvious. Okay, so these molecules, they'll do combustion as well, but we're going to focus on something called oxidation. So depending on the end and how much we can do, there's something called redox reactions. So maybe in biology, if you've taken biology, you talk about Leo says Ger, loses electrons is oxidation, gains electrons is reduction. In organic chemistry, it's actually even easier. So oxidation, carbon is going to form more bonds to oxygen, which makes sense, right? Oxidation, more bonds to oxygen. You can also think of it as fewer bonds to hydrogen, but if you'd like the clue to be in the name, then think of it like oxidation. We're going to bond to oxygen. But these reactions get very, very tricky very, very quickly. So some of you will have noticed when you're doing the reactions homework, they often have like this over top or something like this. Okay, that is, these are catalysts. So again, depending on who your organic professor is, perhaps you're going to have to memorize those. That is not what we need to do here. They're just making, it's like good chemistry semantics to put those on there, okay? They just are required for the reaction to occur because organic reactions are so terrible, they always need something to help them along, okay? Same thing here. So you need something to oxidize the organic molecule, which we call an oxidizing agent. So common oxidizing agents are potassium permanganate. That's what we're going to use Thursday. Acidified potassium dichromate, which is very poisonous, and ozone, which is also, ozone in the atmosphere is good. Ozone at ground level is bad. Okay, so oxidation reactions are good and important. However, they are a little bit dangerous. So, in general, you take an alcohol and you're going to oxidize it. So how are we going to simplify it for you guys? We're going to use the square O. So the symbol O is going to mean the oxidizing agent. So when we use this symbol, that means the equation is going to be unbalanced, 100%, okay? Try not to let that stress you out. Then depending on where the OH is, then that's going to influence whether you get an aldehyde or a ketone. Is it at the end, like a primary one, or is it in the interior making a ketone, okay? And what do you think the other product is? Anyone want to guess? Okay, but we are not going to stress about how we get water because it is not going to balance, okay? We're going to focus on the carbon atoms making more bonds to oxygen, okay? So to produce an aldehyde, you need a primary alcohol. If you would like, we used butanol in the alcohol note. We can use butanol again. Are you looking for Tim Aquin? Yes. Oh, okay. It's okay. I don't need anybody. Yes. Thank you. Sorry, I texted her, and somebody came yesterday, and it was supposed to be Tim Aquin, but it's okay. Sorry. Okay, so the primary alcohol, we talked about when we said primary, secondary, tertiary, how many hydrogens could be lost. This is really where it matters, okay? So we're going to make more bonds to oxygen. So carbon has one bond to oxygen. We're going to make one more. Okay? That means the OH has to lose an H, the carbon has to lose an H, so you get water. The oxygen comes from the oxidizing agent. Please try not to stress about that, okay? Yes. Because I forgot. sorry. Thank you. Did I do it over there too? I did. So wherever the O is, again, when you're trying to do reactions, you look at this whole thing. All of these are boring. Oh, look, there's an O. That must be where the action is. We're going to remember oxidation means more bonds to oxygen. Here there's only one. Now we have two. Okay? Another clue, if it's oxidation, you're going to see this. Okay? Except for, even when we do the lab demo, just even though we're going to use KMNO4, just write the O, okay? Because it doesn't make any sense until you like really go through the mechanism, which is not an expectation for you guys. So we have 1-butanol. Plus the oxidizing agent makes the C double bond O. Where is it? It's at the end of the molecule. That's an aldehyde, and it's butanol. Can you write 1-butanol? Yes, but again, you don't have to, and sometimes people don't because aldehydes have to be at the end. So now for a ketone, you're going to use a secondary alcohol. I'll stick to what was in the example, so we did 2-butanol. It doesn't have to be on number 2, but I'll just keep it with the same one we did before. So still the same thing. We want to make more bonds to oxygen. That means we have to get rid of hydrogens, which is great because we want to get water. And the O for the water comes from the oxidizing agent, but we're not going to stress too much about it, okay? So this carbon this time stays the same. There's no O there. Now this one has the O. We're going to make more bonds to the O. And this is also not balanced. No. These ones will stay. I know that's frustrating. Okay, so then no reaction. The by default, that's probably tertiary. So in this tertiary alcohol, you want to try to make more bonds to oxygen. Can this carbon do that by losing hydrogens? Does it have any hydrogens to lose? No. Okay? So you can't have 5. You can't drop a methyl group. It's either more bonds to oxygen or fewer bonds to hydrogen. Okay? So this one, you can't make 5 bonds. There's no space. So then you would just write no reaction. So in the alcohol note, where we filled in that chart about what was primary, what was secondary, what was tertiary, That's why that stuff at the bottom said how many hydrogens are there. That's why that matters there.